Okay, I think we'll go ahead and get started. Thank you, everyone, for joining us for our webinar today. My name is Aaron Sachs, Senior Product and Technical Training Manager with Hanwha Techwin America. And joining me, I also have Greg Hadley, who will be helping with any Q&A that come up. Today, our webinar, this is our first webinar that we've done, or that we're doing on our thermal camera solution. So this should be very exciting today. So our agenda, we'll do our normal little introduction for the webinar, a brief slide or two about Hanwha for anyone who's new, and then we'll introduce the thermal camera solutions. We'll talk about three main categories of products that we have. We have our standard thermal cameras, and we'll talk about their applications and where they can be used. We have something called a thermal radiometric camera, and then we also have our new elevated body temperature bispectrum thermal radiometric camera. And we'll do some demos and some videos throughout. That depending on time, I might save some of the video clips till the end as well. And then we'll have time at the end for Q&A. So the webinar is being recorded. It will be on our website under training and under their webinars in a couple days. So if anyone misses it or wants to access any of this material later on, you can feel free to go there for that. All participants have been put into a listen-only mode. And again, we'll take Q&A time permitting. If we run out of time, we'll be able to answer those questions individually afterwards. And again, if there's anything that's off topic, we might hold that and answer those separately afterwards. So very briefly about Hanwha, in case you're new to us, we are a global Fortune 500 company. We have our supply chain of trust, which encompasses everything for cybersecurity through R&D, manufacturing, and QA and QC. We develop our own innovative and proprietary SoC, a system on a chip, the Wisenet 7 chip you'll see on the right-hand side of the screen. So we design it, we manufacture it all ourselves in our own facilities with our own people. We have world-class optical design expertise required for things like high zoom optics and for video surveillance solutions across a wide range of vertical industries. And so we are a leading manufacturer for end-to-end solutions in the video surveillance market. Our company is based out of South Korea. We have over 30 years of manufacturing experience specifically for video surveillance. All of our IP cameras, analog cameras, NVRs, DVRs, encoders are sold and distributed in North America, are manufactured, like I said, in our own facilities in South Korea and Vietnam. And we have a full suite of products. All the products we'll be talking about today are NDAA and TAA compliant and available for GSA scheduled contracts. Specifically, these thermal camera solutions, today we'll be talking mainly about the US. Other countries, that's something you have to talk to our sales team to discuss. If you're from outside of North America, you have to talk to your own local sales company because these products are not sold worldwide. And I'll get to that actually on the next slide. So these cameras are part of our Wisenet T series. The T series are kind of the top of our portfolio, as you can see here. They're designed specifically for vertical specialized solutions, so specific industries, specific applications. So we have a wide range of solutions that we offer. And again, we're talking about the specific use case of the thermal cameras today. So, like I said, thermal cameras do have sales and export restrictions. So please get in touch with Hanwha Techwin, either US or elsewhere, about, are the cameras available for purchase? They are not available to all customers or all shipping locations. We can't just sell one and ship it to another location. It's very specific. These are restricted by various federal agencies. And so because of that, we have to, again, restrict the purchase and shipment for ultimate consignee and purchaser locations in the United States. There are very specific U.S. export licensing requirements. There's paperwork that goes with it. Exports without an export license or authorization, or not to the right parties, is prohibited by law, by U.S. and other global restrictions. So keep that in mind. So, what is the purpose here? The purpose is to have a video system that can be used 24/7, 365 in difficult, changing, challenging weather and lighting conditions. So things like fog, smog, rain, smoke, fire, complete darkness, backlit, etc., etc. So when you have things like fence lines where you maybe need to see someone entering a premises or whatever, to be able to to have that visible. So I've got two video clips here I'll try to play. Let's hopefully they will play correctly. Okay, I know there was a lot of information on there that went by quickly. We're going to get into many of the details and the specs and some of the features that you saw. We'll get into that momentarily. And here's just a demo video kind of showing a standard street scene. And again, this could be complete darkness, daytime, nighttime, whatever. And the idea is to be able to see those vehicles, to be able to see the movement, see what's going on. In the previous video, you saw those wind turbines and being able to see are they spinning and how they're functioning without needing lighting on the scene. Okay, so what are the applications? What are the use cases of these thermal cameras? So it's, for any, like I said, any type of application where you need to have very robust, very strict monitoring of your facility. So things like industrial facilities, oil, gas, power plants, seaports, mines. There are some city surveillance applications. Sometimes cities will have protected areas, sensitive areas, trouble spots, or just other things like power plants, bridges, dams, pipelines, borders, warehouses, anything that you need to make sure 24/7 is anyone going into there. So lots of use cases. They're also used in things like mining, like I mentioned, anywhere where you need to monitor sensitive equipment. We'll get more to that again shortly. So the other piece is being able to use thermal cameras for long range detection. We have different models. So this is showing three models, the 13, 19, and 35 millimeter. But again, there's different models. But what they're showing is, depending on the lensing, depending on the model you choose, you can do things like detect an object, detect a person or a vehicle, recognize or identify these objects, all the way out to over 3,000 feet away with the 35 millimeter. So sometimes you have an application where you have a long fence line or short line, whatever it might be, and you want to be able to monitor it without needing lots of cameras and lots of lighting. Thermal cameras can provide that. And again, this is just showing, again, one of those examples here, the 35 millimeter camera, and the different options there of being able to detect a vehicle all the way to recognize or identify. Now, one thing you'll see in terms of the recognition side or the identification is there are some limits to that. You'll see because of the resolution of the camera, but especially if it's someone who you know, you do have that ability to do recognition or identification in some use cases there. So again, just so everyone knows, and this is all in the data sheets as well, detection, recognition, and identification. Detection is being able to detect that there's an object there. You can't necessarily tell what type of vehicle, but you can tell there is a vehicle on the road. Recognition, you can identify the shape of what type of object it is. And then identification is being able to see things like gender, age, are they wearing glasses? You know, if it's a known individual, you'd be able to identify them versus someone else. And okay, so whoops, let's see. So what is, sorry about that, what is a thermal camera? How does it work? You know, we've seen different things in movies, TV, people get confused. There's different technologies out there. So what a thermal camera does is it is measuring the electromagnetic radiation that's emitted from an object, and the radiation it emits is based on its temperature. And it has to do with the vibration of the molecules inside of it, and it's called thermal radiation. So the hotter an object is, the more it's radiating, the more the molecules are moving around, emits a higher frequency, and then we can then see it. So if you think about, if you heat up metal, metal gets red hot and it starts to glow and you can see it more. Same thing here, we're just talking on a different scale. And I think I have another picture to show that later on as well. So Hanwha has a range of different types of thermal cameras, like I mentioned. I'm going to break it down into a couple actually additional categories. So we have our standard thermal cameras available in a bullet style, like you see here. It's a white colored camera. It's a bullet style, so you can install it on a wall, on a soffit, or wherever it might be. And we have two different resolution options. We have VGA and QVGA resolution options. And you'll choose the resolution based on obviously cost, and also based on the area and the distance you're trying to monitor. We have these cameras available in a PT head on just the camera module that will get mounted to a positioning system. So if you have an existing positioning system, to be able to do things like panning and tilting. And then we also have an all-in-one pan tilt unit with the camera all integrated together. We then have our thermal radiometric models, and then the dual spectral elevated body temperature, which is also a radiometric camera. So we're going to talk about all these different pieces now. So starting at the basic, we have our standard thermal cameras. They are available, like I said, in two resolutions: VGA, which is 640 by 480 resolution, as well as a cost-effective QVGA 320 by 240 resolution image. Like I said, we have different lens options, 13, 19, and 35. You'll see more of this on the next slide. And like I said, we have three different types: the bullet style, the pan tilt head, and the pan tilt unit. So on the right, you see on top is the bullet, and below that is the pan tilt unit. So that doesn't have any mounting. You have to mount it to a pan tilt head that has, I think it's just a 1/4-20 thread on it. Other key features, these cameras support H.265 and H.264 streaming with our Wisenet chipset. It can do full 30 frames per second. That's a big differentiator. Some of the cameras on the market either are lower resolution, QVGA, or they are lower frame rate. So we can do 30 frames per second at whatever resolution the camera supports. In addition to H.265, we have our Ystream 2 feature, which is our intelligent codec to help further reduce bandwidth and storage needs. They support hallway mode, so depending on the installation environment, if you need to rotate it 90 degrees for portrait versus hallway mode, that is supported. They do have digital image stabilization with a built-in gyro sensor. They are PoE powered or DC or AC powered. The outdoor bullet models are IP66 IK10 rated. They have a PTZ handover feature. We'll talk more about that later, as well as video and audio analytics. And we'll talk more about those analytics, but one of the important things, obviously, is with a thermal camera, there is a thermal analytics component as well, of being able to detect certain temperatures or temperature changes. So starting with the QVGA lineup, you'll see here the 3 different models. They are all T-series cameras, so they all start with the letter T. So TNO 3010T, 3020, or 3030T. And the only difference of these 3 models is the lens, 2.7, 4.7, and 13.7 millimeter lens options. And those are just depending on the horizontal field of view of how big of an area you're trying to cover, how far away things are. And then from there, we then have the VGA lineup, and these are all 640 by 480. And the 2 options you'll see in the middle, we have the 2 model, in the middle and on the right, the pan tilt head version. And this slide is pretty much a repeat. I'm just going to skip that. And then you'll also see on the right is the pan tilt unit. So if you want an integrated pan tilt device, so you'll often see these again on big industrial locations where they need to be monitoring the whole facility, military, border, tunnels, bridges. You'll see things like that where they want an integrated pan tilt with the ability to look up and look down. A lot of traditional pan tilt zooms are mounted on a ceiling and look down only. So this can be mounted looking up and looking up and down all around. So we have those options as well with the 19 and 35 millimeter options. And so here you'll see again some of the specifications of that model. So full 360 degree rotation, 90 degrees tilt down, 40 degrees tilt up. Okay. Moving on, and again, I'll show some more video clips of all of this shortly. We then have our radiometric camera. So what is a radiometric? The camera itself is even more specific and more accurate in that I can draw a motion detection, I can draw an analytic zone, as you can see on the screen on the right, and I can detect specific temperatures. So you'll see in that orange box on the top, I could say if a temperature goes above 100 degrees Fahrenheit, that might indicate that that equipment at that power plant is having a problem. And I want to be notified right away to take action. So that's what that would be used for. Or maybe I want to monitor an area that people shouldn't be there. If I see something around 98 degrees, that might be a person, that's a problem. That's what the radiometric cameras can do. There's also the ability, besides the temperature zones, is you can also do what's called a spot temperature measurement, where you can click on your mouse and find out what the temperature is of a specific zone on the screen. So that's really what that is there. As opposed to the traditional thermal cameras, look at gradual changes. If the whole room, if a certain area changes over a period of a couple minutes, changes a certain number of degrees, whereas radiometric is much more specific, much more exact. And again, I'll show examples of all of this. So you'll see the basic specs of the radiometric cameras are about the same. We have a 19 and 35 millimeter option, same Wisenet 5 chipset, VGA 640 by 480 resolution, 30 frames a second, H.265, IP66, IK10 rated, 24 volt AC, 12 volt DC, and PoE powered. And I think I've got a video. Let's take a look at this. in that example, in that video, you know, you might have a power plant. You need to know if one of those pipes or valves freezes, gets too hot, whatever it might be, so you could set those thresholds for those analytics. And then so next I want to show some of the feature sets of our thermal camera range. All of the bullet cameras, just like any of our bullet cameras, in the back box that it comes with has the analog video out, the reset button, the micro USB that's used for a Wi-Fi dongle for installation with our app. There's a micro SD card slot, the RJ45 connector, the low voltage power, and an alarm input and output connectors. The pan tilt head, if you're not using the bullet, they're behind cable glands, so you have to open it up a little bit more, and they do not have the USB component because they're going to be on a pan tilt head, so you don't really need to aim and adjust the camera. So moving on to analytics, I mentioned this briefly. So again, the standard thermal cameras have what's called temperature change detection. That can detect drastic temperature changes that occur, you know, over the course of a couple minutes. And you can tell it things like if it changes more than 20 degrees in, you know, those 2 minutes or whatever it is. So that's temperature change detection. So you would put a box, you know, around that piece of equipment, for example. In addition, these cameras have all of our other standard intelligent video analytics, things like virtual line detection, entering and exiting an area, loitering, shock detection, audio detection, and sound classification. So all of our normal analytics are there. They're all license free. They're ready to go. They're built in. And I'll show you at the end of the session today how they are all integrated into the Wisenet Wave VMS as well. We also have with our thermal cameras a range of color palettes, depending on, you know, what object you're trying to see and what the background, what the different temperature differences are. You can choose these different patterns. So a lot of people like the rainbow, for example. There also are some options where you can select specific temperatures. So if you're trying to see people, you know, people are typically around 98. So you can say anything between 80 and 100 degrees, for example, would appear in a red color. So for example, on the bottom right, you see it says red hot or the black hot. You could tell it a temperature range, and those temperatures will then be in that color, and everything else will be kind of black and white. So you have some options and flexibility to choose the color palettes that work for you. So this is what the web page looks like for the temperature change detection. So on the standard thermal camera, so you can set up to 3 zones. You draw the box on the screen. You tell it what the temperature difference is, 20, 40, 60, 80, 100. You tell it centigrade or Fahrenheit. You tell it, is it the minimum temperature, maximum, or average? So you can say if the temperature falls below this, if it goes above this, or again, the average temperature. And it looks at the last 2 minutes worth of data. It's also important to know that there is specific temperature ranges that the camera is designed to be working in and detecting. So that's what temperature change detection analytic is. When we go to the radiometric camera, you'll see here I've drawn a box. Again, we have 3 boxes, A, B, C. We draw the box on a specific area, but now we have a lot more control. We can again say things like minimum, maximum, average temperature. We can tell it when it goes above or below. And then we put in a specific temperature. So I put in 104 degrees, and then we can tell it what the duration. Maybe it has to hit that temperature and stay there for 30 seconds before it triggers the output. We can also turn on an overlay on the video where I can put in the minimum, the maximum, and the average temperature. We also have an adjustment for the emissivity. The emissivity has to do with what type of object you're looking at. If you're looking at plastic versus glass versus certain types of metals or whatever, you can look up on the internet what the emissivity is of how reflective that object is for the heat that it's radiating, and that will help fine tune the performance of the camera. Yeah, so if you enable the temperature overlay, then you'll see here there's the 4 boxes: average, the area, average, minimum, maximum. That will be overlaid text onto the video stream, burned into the video. There are ways to get that data in the metadata of the camera. So if you have a VMS or another application and you want to be notified when the temperature goes above 104, or you want to be notified when area A triggers, that can be obtained through the API. But most VMS are just going to say, oh, event or event on area A. But that is capable of being done. And like I mentioned, we have all 3 codecs: motion JPEG, H.264, and H.265. So that way, integrating into different VMSs. If you're using Wisenet, NVRs are VMS. We can obviously, and we recommend H.265 for bandwidth and storage savings. Like I said, we also have our Wise Stream. So again, these are very low bandwidth video to begin with, because it's VGA and QVGA resolution. But we do have Wise Stream, so that way when there's cases or times where there's low motion, it will do even more compression to help reduce further your bandwidth and storage. Another cool feature that you saw in one of those first videos was the PTZ handover. So you could have a thermal camera using the thermal detection to detect whether it's motion, temperature change, analytics, virtual line crossing. So I can see when there's no light, people walking in an area that shouldn't be there. I can then have that trigger an event that tells my PTZ to go to a specific preset to zoom in. So we have a range of PTZs that have ultra long range, high resolution, and built-in IR to light up the scene. So this way, we don't need to have lighting all over the place. We can still be monitoring the area, but then still get higher resolution using the PTZ handover feature. And Wave integration. So with the latest version of Wave, we now have our plugins. There's a plugin tab that you right click on a camera, go to camera settings, and that's where you can now configure analytics. And we now have the temperature change detection, or for the radiometric, they called it the box temperature detection. And you can enable it. You can draw your zone. You can choose the type, the minimum, maximum, the average, above, below. You put in your temperature, your duration, your emissivity. All of that can be configured right through the Wave interfaces, along with the other analytics that you see on the left-hand side. On the right, we can now create event rules to say when this camera has a temperature change detection analytic from the thermal camera, do an action. That action could be bookmark the video, pop it up on the screen for a guard watching it. It could do a mobile push notification to your mobile app. It could play a sound file. It could play sound out of the camera if you have a speaker connected to a two-way audio. So there's lots of options there that is now integrated in the latest version of Wave. And with that, I want to show a couple video clips, a couple of different demonstrations before I then go on to the next topic. So bear with me for 1 second here. So I know we talked a lot about this, and this is just to help, so it's not just so conceptual. But this is me walking around the front of my house. And you can see all these different, temperature elements. We can see the street. Different parts of the street are warmer. You can see the sidewalk. You can see the shrubs. You can see the house. You can see the windows are warmer because light leaking through the windows. You can see when I was walking by, obviously I'm a hotter temperature than the surrounding area. Another cool one we were playing with our thermal camera to learn about it, and I just need to find it here. 1 second. And we were in a conference room. This is before COVID, when people were allowed to be near each other. And we saw that actually a section of the wall where my mouse is was warmer than others. There must have been some pipes or something in the wall. Someone then rubbed the wall with their hand, and you can see the heat from their body heat being transferred to the wall. So again, showing how different parts of our body are warmer than others. You can see someone wearing glasses, you see the reflection. And then one of our guys put his handprint on the wall and moved away, and you can see that visual, you can see that handprint being left behind the latent temperature signature there. And let's see, I believe we got one more here. There we go. And here's again the outdoor scene and just showing cars driving by. So you can see cars are that white hot color versus some of the other things there. But you'll see some parts of the car are shiny or reflective, the windows, and you can see the hotter engine as well in the front of the car. And then one last one I'll show here is this was a demonstration done at a school over summer, where they did a what they call smoke cloak, a smoke test. So some people want to use thermal cameras to be able to see through smoke and fog. I think this school here was also doing something to stop a mass shooting incident of being able to fill a hallway with smoke to stop an intruder because now they can't see. But you'll see here how the thermal camera is able to see through that. I'm going to just fast forward so we don't take too long, but you'll see on the left, eventually the hallway gets completely covered with smoke. You can't visibly see anything, but on the right-hand side, we can see completely fine through it. So again, a lot of different useful ways of using thermal. Again, a lot of times in industrial locations where visibility is critical in some of these situations that could come up. Okay, and again, any questions, feel free to put them into the Q&A and we'll get to them at the end. And then the second half I wanted to talk about today is a new camera that we recently launched. That falls into our thermal camera lineup as well. This is our elevated body temperature camera. So obviously with COVID, there's a lot of interest in this for a variety of reasons. So this is a purpose-built bispectrum camera. So that means it has a visible sensor you can see on this picture on the left side, and on the right is the thermal camera. So it has two camera heads in it. It has AI built into it as well. We'll talk about that. It can detect one or multiple people. It is accurate with a black body calibration reference device to 0.54 degrees Fahrenheit. Without the black body, 0.9 degrees Fahrenheit. And the visible camera gives you verification and identification, because like we said, the thermal camera sensor, those can have limited resolutions and it's hard to positively identify who someone is. So this gives you more visible information for identification and verification. And finally, this camera is FDA 510K approved. So like I said, it has two cameras in it. On the left is the visible 2-megapixel camera with a fixed 4mm lens. And on the right is a thermal imager, QVGA resolution at 4.7 millimeters. And you'll see this camera has two different modes it can operate in. And you'll see some of the questions coming in. Hopefully we'll answer this. So out of the box, this camera works as a radiometric camera. So everything we talked about before for your industrial applications of being able to check, you know, are the pipes running? Are things running too hot? Is the transformer getting too hot? You know, whatever. Or it could be used outdoors for, you know, again, detecting forest fires or tunnels and things like that. So that's the normal radiometric. The benefit of this is I also have a visible camera. So that way, when it's not pitch black, when you have it in a normal environment that's not filled with smoke, you have both sensors to work with to get more information available. You can also put the camera into the estimated body temperature mode, which is what we're seeing now with COVID time. So when it's in that elevated estimated body temperature mode, then it has specific analytic that it's doing, looking for that high temperature. We'll get to that in a minute. In the radiometric mode, it has all the analytics we talked about a few minutes ago, including the those 3 zones and being able to detect specific temperatures. So when it's in the estimated body temperature mode, it's doing face detection. It's using an AI chipset to detect that there's a person with a face there. So in this case here, there's a mannequin. The mannequin doesn't have a heat signature. It doesn't have the same heat radiating off of it as a person. So even though there's a face that a visible camera might see, it's not getting fooled by that. Same thing, if someone walks by with a hot drink in their hand, some thermal cameras will say, oh, that's a really hot drink. That's someone with an elevated body temperature. Whereas here, we're able to say it has to be a person with a face using the visible camera. We transfer that to the thermal camera and then look for that temperature or look for that elevated temperature, I should say. So it uses them together in that way. And you're then able, through your VMS or whatever, you can then be monitoring and recording both channels. I'm going to show a video. I think it's about a minute or 2 long, so just bear with me with that. But hopefully this will show you an overview again of what this camera can do. Again, I see there's a bunch of questions. We will get to that. Okay. So it's very important for any elevated body temperature or screening. There's very specific installation environments that you're supposed to follow the installation. And you saw a lot of that in the video. The FDA, along with some other agencies, do have recommendations for that. Um, it's recommended that there be a black body that's a reference calibration device. It's a separate accessory that we offer. Should be at the same distance and height as the person's head that you're evaluating. You will see here these examples here are showing a camera on a tripod. That's typically just often with this, people want to quickly be able to get these up and running. As someone asked in like one of the questions, the camera can be mounted from a ceiling or a wall. We do have accessories. We do have a way to drop it down from a ceiling. The important thing is the angle and whatnot, that the camera should be at the same plane as the person's head and not at an angle high up on the ceiling, because then you won't get the right amount of pixels and viewing the right, you'll be viewing the top of their head. So yes, it can be wall mounted or from a ceiling, but need to take some of those items into consideration. It's also important to set up a queuing area like you saw in the video. You don't want to have the camera pointed right at the doorway, because then when the door opens, you'll be getting the cold or hot air from outside, or the windows, reflections from windows will cause problems. You also want to have time for people to stabilize their temperature in a queuing area. So ideally you set up a dedicated area that has some social distancing and some guidance and where to stand and where to look and all of that. And then also it's important to know that if someone has an elevated temperature, like you saw in the video, that you should have some sort of secondary screening, such as an FDA approved medical grade thermometer, whether it's forehead, non-contact, any of those, and use that to confirm or deny entry based on your testing. I'm not going to go through all these slides. We have some other webinars that will do more technical sessions for technicians, but there are various settings, again, it's all through the web browser. It's all responsive web. You don't need any plugins, so any browser, any machine will work. And you tell the camera, is it normal radiometric mode or estimated body temperature mode? You tell it, are you using centigrade or Fahrenheit? And there's a couple other options as well for that. And then once you do that, there's options to adjust where on the face to look at instead of looking at the whole face. Typically your forehead is very warm, so being able to get it closer to just the eyes, as well as if you have that black body, where is it coming down here, being able to configure it for the black body, being able to tell it, if you know the temperature and humidity of the room based on your thermostats and whatnot, you can again help configure the system to work properly there. And then there's again other setup menus. I'm not going to go through all of that right here, but then again there's some options in terms of the temperature. If the temperature goes above or below this, what is your alarm set to? If the black body has a error, should it send an alarm? There's a beeper or a buzzer on it. You have alarm outputs as well as finally integration to different VMSs. So, and with that, I'll show a quick demo. I think there was actually a couple videos in there that I probably forgot to show. Let me just see if I can find it. Here we go. And so you can see here when the person's walking by, here's someone just standing there. This is what the thermal image looks like, and it shows you the temperature reading for that person right there. Let me show, actually, I'll show it live here. This is in the Wave VMS. And again, one of the questions was saying, do I have to use the Wave VMS? Absolutely not. The camera is standard ONVIF compliant. So it works with any major VMS. It shows up as a multi-sensor camera, so there's 2 channels. In terms of getting the temperature analytics, that you have to ask the VMS of, have you integrated that feature? Have you integrated the VMS, the analytics? Have you integrated the metadata to be able to find out more of the zones and the temperature readings and all of that? So obviously the Wave VMS, I can speak for that. I can't speak for other VMSs and how they've integrated that. Someone was also asking about audio. If you don't want to use audio, it's turned off by default. You don't have to use it. But the cameras all do have the audio in and out feature. So on the left is the thermal image, not much to see because it's looking at a doorway. On the right is the visible image. Obviously, this is not the best installation environment because it's very short distance to the door, as well as I don't have a black body set up right now. But just to show you guys an example, I'm going to do a smart search and see when there is movement in the doorway. And I can see on the right-hand side when people came in or out. And we'll wait for the person to turn around. And you'll see that when you see the person, you get that overlay showing you green for good, and what their temperature is. If they were too hot, too cold, it would show up in red. Again, the numbers might not be 100% accurate. It's showing 95% because we don't have a black body. And this camera is mounted in a lab with it's a server room. So it is very cold in there typically. And there are some adjustments in the camera to tell it the ambient temperature, ambient humidity. So out of the box, it might not be perfectly calibrated. But again, most importantly, because I do not have that black body reference device there. But again, one of the key benefits of this camera, let me get another clip going, maybe. Oh, I didn't hit play. There we go. Is like someone was asking one of the questions, is that when you have a thermal camera, your resolution is limited. I can pull up my information here and you can see, oh, actually, I'll get to that in a second. The resolution is actually 320 by 240. We actually are kind of fooling it a little bit. We stretch the image to be 1280 by 960. That way the OSD, the on-screen display, is readable. Someone else was also, as you'll see on the right, I can now see what color shirt he's wearing, what color pants, is he wearing a mask, all those things. So someone was asking in the questions, if I just had the thermal image, I wouldn't be able to tell what color clothing he's wearing, if I didn't, if I know who this person is, I can identify that, yeah, that's Bart. And so that's the idea of being able to recognize or identify someone. If this was an unknown person, I could say that's not Bart, but obviously I wouldn't be able to recognize who they are because there just aren't enough pixels there. On the visible image, because they're side by side and they're included, so now I'm able to see a lot more detail of who that person is. So the overlay that you see here, this is how it shows up with the little hash marks and the temperature. If you have more than a certain number of people on the scene, I think it's more than 2 or 3 people in the scene, it will then shrink. It'll get rid of the temperature reading and just show you red and green in case there's a problem. But that is how the temperature display shows up on the screen there. And with that, again, in the Wave VMS, it's very easy. I can just search for motion or other things, and I can create events and rules to have it do things, to have it pop up, bookmark video, whatever I want to do there. Again, everything is done in the web browser. There are a couple additional menus of configuration for the elevated body temperature camera. So there are some settings to configure for that. Does show up in most VMSs as one camera with 2 sensors. So typically you only need 1 license for that. And I would recommend get in touch with our regional sales managers if you're going to want to put in one of these systems, just to make sure it's designed properly, right? We don't want you to put it in and again not follow some of those guidance and guidelines from FDA and other people, then you won't get the accuracy that you're looking for. So feel free to reach out to our sales team. And with that, I'll see if any other questions come in. But I want to thank you for your time. Again, thermal cameras are really, I think they're really fascinating. There is some education involved, like we talked about, in that, it's not seeing what you can see with your eyes. And so sometimes different objects, different materials interact differently than you might have thought. Again, typically people want to see people, and so that works very well. If you have specific industrial applications that you're looking to do, that's where you should take to do a demo or see how that material interacts, how it shows up on screen on a thermal camera. With that, my contact info is on the screen if anyone has any questions, and then I'll take a look at some of these other questions that came in. So Greg is asking, in EBT mode, what analytics can you run? So in EBT mode, you can only run the elevated body temperature. That's it. When it's in standard or radiometric mode, that's where you have the temperature change detection. You have the virtual line, the virtual areas, and loitering and shock detection. In EBT mode, all of those get turned off, and it's only running elevated body temperature analytics. Um, Someone's asking a question about alarms and through the network. If I'm understanding that correctly, so these cameras will have an alarm input on the back of the camera. You can run a hardwired connection to the camera. That alarm gets triggered. That would then get sent back to my VMS or to my NVR. And the NVR would then receive that as a network-based alarm to then take an action. If you were trying to land it on the NVR as a dry contact or something, then you would need some other box to take it onto the network and off of the network. But typically that's all done through the network. The camera receives the alarm in and then delivers it to the NVR through the network. Oh, good point. Hank is asking about things like strobe lights or being able to play a sound. I should have mentioned that too. The EBT camera does have alarm input and alarm output. So yes, you can have a strobe or a speaker connected to the camera and say when an elevated temperature is detected, it flashes the strobe light. Yes, you can also have, you can upload a audio clip into the camera that says, you know, an elevated temperature has been detected, please wait off to the side, or please wait for our staff. And you can connect a speaker to the camera, and the camera can play the recorded sound file out of a connected speaker upon activation of that event. So that is possible as well. And yes, all of our cameras are ONVIF compliant. We are a member of ONVIF. We're on their technical committee. We use we do have an API available, our own Sunapi Smart Unified Network API, or you can use ONVIF. The metadata is all transmitted via the ONVIF metadata service. So you can use that to look at the events and the metadata as well. And about kits, this is the camera. This is what we offer. Look at the data sheet for the camera. You'll see the accessories. So things like mounts and the black body are available. But anything beyond that would be done, like you said, by the integrator of making a kit or multiple SKUs or whatever that might be. Right. So Hank, right. So that really depends on the flow, right? If you have an entrance that has lots of people, lots of lanes, turnstiles, whatever, right, you could have, if you're following the FDA guidance, you're supposed to be screening one lane, one person at a time. So you could have multiple cameras to look at multiple lanes. The camera technically is capable of screening multiple people. The turnstile you saw earlier, I could have people in multiple turnstiles. The camera is technically capable of detecting the temperatures of each person individually. But again, FDA guidance would say one person, one lane per camera at a time. So take that for what that's worth. Again, I'll stick around. Any other questions keep coming up, but we're top of the hour. We finished the material. So again, thank you all for joining. And check out on our YouTube channel. We have some of these YouTube videos kind of showing what the thermal cameras look like. And we have some other videos that, again, if you want to see kind of how a thermal camera interacts with different objects, different materials in indoor or outdoor environments, it's pretty cool seeing it. And just remember, again, a lot of what you've seen on TV and movies isn't always legit. You know, they edit things in studio. But being able to see what a thermal camera, what it can actually show you, what it can detect, it's important to know what it can actually do. And if anyone has any other questions, we're happy to, anything on the Hanwha side, we're happy to take any questions you may have. All right, someone was asking about the OSD, the on-screen display. So I'll pull up the web page and we can take a look and see what options there are there. I don't recall offhand. I believe it is fixed for the elevated estimated body temperature that's on the top of the image, that just like you saw it. Let's see if I can open it up. This camera is remote. So let's see what my bandwidth is doing. No, that doesn't seem to want to. Now I have to remember my password. And of course, I don't remember my password, so scratch that. Well, I don't see any other questions. Oh, well, let's try that again. There we go. Thank you, Greg. So this is how the camera comes up, the two channels left and right. We can go into setup, and again, it just looks like any of our other multi-sensor cameras. Hank's asking about demos. Yes, please get in touch with our regional sales managers, and they can let you know about who has access to demo stock. And let's see about the on-screen display question. Let's see any options there might be. Sorry, my machine's always a little slow when I'm on Zoom, just broadcasting my desktop here. Yeah, so there's no option for changing the positioning of the overlay. We can turn it on and off if we don't want to see it. There's the beep. There's a minimum duration, the minimum temperature. And that is the only option for that there. Yep. So all the configuration for the EBT is done in this menu here. Here's the analytics section. And then there's also the initial setup of the camera in terms of, here it is, under temperature setup in terms of what mode, Fahrenheit, Celsius, and which color pattern to use. Hank, yeah, I can't really answer that on this call here. We don't want to be talking about competitors specifically. I would talk to regional sales managers about that, and they can get you more info about that. If you need to know how to find your regional sales manager, you can go to our website, hanwhasecurity.com, go to support and sales, and we'll list our sales regions, and then you can just mouse over and see all of our regional sales managers to get a hold of them. And what I will say, Hank, and I should have said this earlier, but there are a lot of companies making EBT devices. Ours is one of the only that is FDA 510K certified. Most of them on the market say they're not a medical device, don't use it for this, don't use it for that. Ours is actually designed and developed specifically for what we talked about today. Again, any other questions, feel free. We also have certification from various other agencies, UL, things like that. So, it's a purpose-built device made in Korea, I believe. Okay, well, thank you everybody for joining us, and we look forward to seeing you next time. Have a great day, everybody. Stay safe.